Hello everyone, this is Prashanna Shrestha and this is the summary for network design. Case study introduction. The case study is of Ballarat Technological Park of Federation University Australia that owns 300 employees with a 150 computer network. The computer network is old and it needs to be replaced. So for the designing of the new network, we use building block network designing process because it accurately predicts user traffic, builds networks by using a few standard components to simplify design and reduce costs. Building block network design process involves three steps. They are as follows: need analysis, technological design, and cost assessment. Talking about need analysis, some network architecture components. LAN. Entire computers for the university can be connected into LAN using the star topology. Building backbone. According to the given requirement for connecting all the ports together, a Cat6 cable is used, which will be the backbone of the building. Campus backbone. Fiber optic cable is used as a campus backbone because of its high bandwidth in compared to Cat5 and Cat6 cables. Data centers. For the case study, a cloud-based data center is designed. Application system. Key applications and services provided by the university include internal applications such as payroll system, file servers, and external applications such as web servers and email servers. The protocols used by web servers and email servers are Simple Mail Transfer Protocol, File Transfer Protocol, and Post Office Protocol. Talking about network users, to understand network traffic patterns, typical users and high traffic users are separated. There are high traffic network users and four typical network users. Categorizing network users. High traffic users use time sensitive applications and services such as video conferencing services and other web services. On the other hand, typical users use network for simple desktop and web applications. Deliverables. The final deliverable after completing the assessment process is the logical network diagram. It is the conceptual plan of the network. Here is the picture of logical design of the network. Campus core backbone that connects administration building and office building is facilitated by cloud data center, which is connected to the internet. Administration building has high traffic network users, while office building has five typical network users and three high traffic network users. Technical design. Designing client and servers. Typical users are allocated base-level client computers, and advanced users and high-end configuration servers like e-commerce servers are used for executing or hosting the applications. Designing circuits. The fundamental technology used for the network circuit is Ethernet, with Cat6 cable used for building backbone. The capacity of circuit varies from 1 Gbps and 10 Gbps. Network design tool. For modeling a diagram of the proposed network is created using draw.io. Here is a picture of physical design of the network. Campus core backbone is connected to the internet, which is facilitated by cloud data center. There are two routers connected to the campus core backbone. Router 1 is connected to the administration building, while router 2 is connected to the office building via a firewall that is used to protect the network from external attacks. Talking about administration building, a 10 Gbps core switch is used to connect to other devices such as printers, PCs and laptops, and also e-commerce edge server. E-commerce edge server is used for hosting and executing e-commerce for the university. Now talking about the office building, a 10 Gbps core switch is connected to 5 different distribution switches that are of 1 Gbps. Such distribution switches are then again connected to different devices such as printers, smartphones, and computers so that the employees can use them as per their need. A wireless access point is also connected to the core switch in the office building so that employees can use Wi-Fi as needed. In the office building, there are 24 computers on each floor and 120 in total, whereas there are 30 computers in total in the administration building. Reflective thinking of network design. A three-tier network design is suitable for the provided case study, that is routers on top tier, core switch in middle tier, and distribution switches on the bottom tier. The design is done in such a way that it incorporates all the network needs, network components, and the network users. It wasn't possible to include all the 150 computers in the network, hence, only a few are shown in the network design. However, the number of computers on each floor of both the offices are clarified. Interference. A Wi-Fi access point on different floors must be deployed in such a way that there is minimal interference. Antenna consideration for access point is a great way for minimizing the interference. In case of interference, general omnidirectional access point lowers their physical data rate so that the packet loss is controlled. This type of access point is used where the network is used by typical end user, that is on floor 2 east and 2 west LAN and floor 3 east and 3 west LAN. Therefore, the lower data rate will not impact heavily on the performance. When interference is experienced, a smart antenna can select a single pattern with attenuation in the direction of the interference, thereby increasing signal-to-noise ratio and obviating the need to lower the physical data rate. This type of access point can be used on the administration building and the fourth floor of the office building where the network is used by advanced users. Assumptions. The first assumption is to select an IP address for the company which is assumed to be a Class C network address. The assumptions of the address are given given below. Network IP address is 192.168.10.0. Gateway address is 192.168.10 plus zero point zero 0.01, and subnet address is 255.255.255.0. The network is designed in three-tier architecture, that is router is at top tier, core switch is at the second tier, and distribution switches are on the bottom tier. Start topology is selected as LAN topology, in which a centralized core switch of 24 ports is placed on the first floor of the administration building connected to 5 different distribution switches of 24 ports each. The centralized switch is of 100 Gbps, whereas the distribution switches are of 1 Gbps. Assumptions continued. A firewall is used for the office building in order to maximize network security. An e-commerce web server is assumed to be hosting company's e-commerce edge. A cloud-based data center is assumed to facilitate the data center of the university. The access point is connected to the core switch that allows employees to bring their wireless devices such as laptops and smartphones. A demilitarization zone (DMZ) is used on the fourth floor of the office building in order to provide an additional security from external attacks. Conclusion. According to the case study provided, both logical and physical network was designed successfully. For the network design, building block network design process was implemented, and for modeling of the network design, draw.io was used. A three-tier network architectural design was prepared in order to incorporate all the necessary requirements of the case study. Thank you for listening. If you have any doubts, please feel free to ask any questions. Thank you.